How many of you seen the movie Groundhog Day with Bill Murray? One of the classics, one of the best movies ever. Now those of you that haven't seen it, that's what you got to do this weekend. You got to go watch the movie. In it, Bill Murray is stuck in Groundhog's Day. He's got to live it over and over and over again until he gets it right. And every day is the same. Every day these same things happen. And so let's suppose that I'm stuck in Groundhog's Day. And one day I notice that at 4 o'clock in the afternoon there's a collision between a little red car and a great big truck. No one gets hurt. It's fine. But the geek in me is a little bit curious. And so the following day, which is the same day, which is Groundhog's Day, I'm standing at the side of the road right at 4 o'clock waiting for these two to collide. And right before they collide, I slide this bathroom scale between their bumpers and the driver of the red car. Oh my, that's a big number. Now the next day, which is the same day, which is Groundhog's Day, I'm back again at 4 o'clock, and this time I've got the bathroom scale this way. And right before they collide, I slide it in so that the trucker can see the number. Oh my, that's a big number. Who sees the bigger number? The little red car or the big truck? Newton says the same. But he's dead. Do we really believe it? I mean, the truck was loaded down with gold. That was why I was interested. It was speeding because it was late. Is the force really going to be equal and opposite? Do you really believe that? Let's find out. I have here a way of measuring force. I have here these force probes, and what they measure is just how hard you push on them. I'm going to zero them out. And this one measures how hard I push on it in red. And this one measures how hard I push on it in what's supposed to be blue, but is whatever. Okay? Now what I'm going to do here, I'm going to zero them out again. And I'm going to give myself some more time because I'm not that fast. Okay? And I'm going to collect and okay. Now, let's blow this up. Now, that's messy. There's a lot of ringing going on. It's a complicated force. But if you look, whatever happens to one car happens to the other one exactly the opposite direction. Whatever happens to one car happens to the other. It's just a mirror image. Now I got to tell you, in 1998, I was team teaching this class with Jeff Adams. We received those force probes on the morning that we were supposed to teach about third law. We did not have time to play with them. And so we just took a gamble. We said, hey, why don't we try it during lecture? So the first time we ever used these force probes was during a lecture like this. The cards collided, and Jeff and I just stood there. Oh, it's true. I mean, we taught it for years, but we didn't believe it. But it's true. And then the rest of the lecture was over, because after that we did it again and again. We parked this one and we rammed this one really fast. We put a lot of weight on this one and we rammed it back over. We could never get them to be different. They were always exactly the same. It's the most beautiful thing in the world. Now, in case the technology didn't work, I was going to say, there you go. Nice.